So remember our rules, right? We draw the vectors tail to head. The length of the vector represents the magnitude. Make it point in the direction that it is going. All right? Give those a try. Okay. Oh, I left it recording the whole time. All right, let's give this one a try here. So the first thing I need to do is draw the two vectors, or rather, draw the first one. Okay, I need a line that's 8.5 meters long that points due east. Yeah, that's pretty easy. Okay, so I'm going to just do this. Say it's 8.5 meters, and it's pointing right due east. Then, and you don't have to necessarily do this in different colors. I mean, if you don't have different colored pens or whatever, it's fine. I just do it because it's clearer up here. Okay, the next one is 5.7 meters, 30 degrees north of east. Now that has to go on the head of the first vector, because first it did this, and then it's going to go off in this direction. So I'm going to draw myself a reference line that goes due east. Okay, so I know where to measure the 30 degrees from. Now, how did I know to draw it east and not north?
Because it's north of east.
Because it's north of east, exactly. The angle is measured from east going north. All right, so 30 degrees, probably looks something like that. 30-degree angle. I think my scale's half decent here. Okay, at least that line is more than half as long as the first one. Yeah, it's good enough. It'll do. Okay, it doesn't, like I say, you don't have to measure it exactly. Now, where would I draw a line that represents this object's total displacement?
The line from head to tail?
From here?
Yeah.
Yeah, to there.
Yeah.
Yes, okay? Remember, displacement is your change in position. It is the straight line distance from your initial position to the final position. Okay? It's important to remember that definition when we're doing questions like this. So I would just draw a line, okay? Going that way. That is going to represent my total displacement. Now, it also has a direction. Okay? It would need its own triangle as well, so I could figure out how far north it is and how far east it is. Would you agree? Okay, so I'm just going to draw that here as dotted lines. Okay, I could have drawn it here, but I didn't want to draw over my existing lines. Okay. All right, so here's where the new part for today comes in. If I want to figure out how big D is, I can't use Pythagorean theorem yet because I don't know how big its two sides are. But could I find out how big they are?
Yeah.
I could, because this side here, its x, or horizontal component, would be the sum of 8.5 meters east and the horizontal component of this line, right? Because when I'm going this 5.7 meters, 30 degrees north of east, I'm going east and north. Fair? Okay, so is there a way, since I know the hypotenuse of this triangle and I know this angle, for me to calculate its horizontal and vertical components?
Yes.
Yeah, I just have to use trig. Okay, I know the hypotenuse and the angle, which means I can use sine and cos here, because I'd be looking for the adjacent side, that would be x, and the opposite side, that would be y. Okay, and you thought trig wasn't going to have any use. Physics finds a use for most of the math you take. Okay, all of it. But eventually, okay, that stuff you learn in math, physics will make useful. Because when you learn in math, it's just math. Now it's useful. Now it does things. Okay. All right, so what trig function do I use if I want to find the adjacent side and I know the hypotenuse and the angle? Cosine, right? Remember, our rules are so, right? Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And TOA, tan is opposite over adjacent. Okay, that one's out because I don't know the opposite and adjacent sides right now. So if cos of theta equals the adjacent side over the hypotenuse, and I want to find the adjacent side, what do I do with the hypotenuse?
You times it.
I multiply it over to the other side. So if I take the hypotenuse, 5.7 meters, and I multiply it by the cos of 30 degrees, I'll have that side. Agreed? Okay, this is what we call finding or resolving vector components. Any angled vector has an x, or a horizontal component, and a y, or a vertical component, because they're going over and up. If it's diagonal, it goes some over and some up. Okay, this allows us to find out how much. All right, so let's do that first calculation. We know that x, then, our adjacent side, will be the cos of 30 degrees, okay, times the hypotenuse, 5.7 meters. Okay, so I'm going to take, oh, your calculator's got to be in degree mode. I think we did that yesterday, but just double check. If you have math right now, you're probably going to be switching back and forth. Okay, cos of 30, close the bracket, times 5.7. Okay, so x, or the adjacent side, is 4.936. Significant digits. I keep all those decimals in my calculator. You don't have to write them all down. I never do. It's a pain in the neck. But I keep them all in my calculator, right? I'm just going to write 4.94 just to save time. Okay, so this side here is 4.94 meters east. Okay. Now, I want to find y. Which trig function will help me find that if I have this angle and the hypotenuse? This side is opposite this angle, right? Because it's not touching it. Which one uses opposite and hypotenuse? Sine. Okay, so if I want to find y, I'm going to do the same thing I did here, except I'm going to put in sine. Sine of 30 times 5.7, so that should be 2.7, no, I'll just put it in the calculator. I'm not mathing this morning because I forgot to bring my coffee in until just now. Sine. That's my excuse, and I'm sticking to it. Okay, 2.85. That's what I was going to say. Sure, you work. Okay, 2.85 meters. 2.85 meters north. Okay. So now, do I have the ability to figure out what red X is? Because this is a rectangle, right? This side and that side have to be the same, right? So red X, okay? Red X is actually 8.5 plus 4.94. Okay, so if I do that, but I use all my decimals, remember? Okay, so I'm going to use that number there, plus 8.5. So in total, this object travels 13.44 meters east. Okay, so red X is going to be 13.44 meters east. I'm going to keep all those decimals in my calculator because later trig calculations, they're going to matter. Okay, now I also need to know how much north I go. Do I already know that? How far north do I go, Eric? 2.85 meters. Okay, you can do it from here. I want the magnitude and the direction of my total displacement. Give you a couple minutes. All right, so to finish that off, we got to do Pythagorean theorem, right? We need to know the hypotenuse. We have A and B. So to get that hypotenuse is just D equals the square root of 2.85 squared plus the 13.44 squared. Now, I'm only writing that much, but do I need the whole number? Yeah, from my calculator, I need all of it. I'm squaring it, and I got a whole bunch of decimals. They make a difference, especially if you're squaring it. Okay, so you don't want to round off until the very end. That's one of our rules with significant digits, is don't round off until the end. Okay, so I'm going to go square root of that number squared plus the 2.85. Now, it doesn't have any more decimals than just that, but whatever. Okay. So we have 13.735, okay, I'm just going to write it all in there, 13.735 meters. Okay, then I need to get this angle, all right? At this point, you can use your favorite trig function if you have one, okay, because you know all three sides of the triangle at this point. My favorite is tan, because that's how I roll, okay? So the tan, inverse tan of the opposite side. So for this angle, the opposite side is the 13. Okay, divided by the adjacent side, 2.85. Okay, so I'm getting an angle of 78.02 degrees. Which direction is that?
East and north.
East of north, right? The angle is touching due north and going east of it, east of north. Okay, so now, how many significant digits do I have in my answer? 2. Every number I was given had 2. 8.5 has 2. 5.7 has 2. 30 has 2. Okay, so I would have to round this to 14. So my final displacement will be 14 meters at 78 degrees east of north, or I would also accept its complementary angle, 12 degrees north of east. That's what you would have got if you drew the triangle this way. Okay? Your sides would have been the same. but your angle would reference east instead of north. Doesn't make it any less correct. Those two numbers point the same way. All right? Everybody kind of following me there? So what we're going to go over today, and what we're going to be working on for quite a while here going forward, is resolving a vector into its components. That's what we did with the blue triangle, okay, calculating its two sides, and then using what we call vector component addition to solve for a bigger one. Okay, we took the two x components and added them together to get our resultant, or our total displacements, east or x component. And we took the y components, this one didn't have one, and put them together to get our resultant y component. Okay, so here's the good news. You know how to do all the skills already. You know how to use trig, you know how to do Pythagorean theorem, that stuff you know. You're just applying it to something new. Okay, so yeah, are you going to have to flex those trig muscles a little bit and get them back in shape? Yep. Okay, but in the end, it's something you already know how to do. Okay, and it'll come back to you. All right, well, let's go over the nuts and bolts of this, just so that we've kind of covered the notes here. We've seen it used. Now it's kind of, let's talk about the instructions, and then we'll do some more examples. Okay, so the first thing we want to be able to do, as we said, is resolve a vector into its components. That's what we did with the blue triangle. We found its x and its y using trigonometry. Okay, and then use how to use vector components to add vector quantities, or what we call vector component addition. Okay, so here's what we did with the blue triangle. We had the hypotenuse and we had the angle, and we wanted to figure out how far over horizontally does it go, how far up vertically does it go, right? And all we did was use sine and cos to do it. Okay? Everybody with me there? Okay, so to find the x and y components, this is what we did. Okay, we discovered that x was adjacent, so we went hypotenuse times the cos of theta and got this side. We found y was opposite, so we went sine of this angle times the hypotenuse, and we got those two sides. Is y always going to be opposite? It isn't always. It depends how the triangle gets drawn. Okay, if I drew, if the triangle just happened to be oriented differently, y could be the opposite side. Okay, so like let's say I had, okay, this triangle here, and I knew that this angle was 60 degrees. Well now, okay, well, no, I did that, sorry, did that wrong. I made it exactly the same as what we just did. Okay, let's say I drew it, permutations and combinations here. Okay, like this. So now, this angle here is, I don't know, 35 degrees. Well now, y is adjacent to it. Okay, so y isn't always opposite, x isn't always adjacent. You have to build the triangle and figure out which one's which. Okay, so this is what we did with the blue triangle. Okay, we said this angle was 50. We knew that the hypotenuse was 175. For this one it is anyway. Okay, so to find x, we simply plugged in cos, and to find y, simply plugged in with sine, and we got those numbers. Okay, everybody's good with the trigonometry part? Okay, so that's resolving into components. Then what we used that to do, okay, was if I had, let's say, this vector and this vector, and I'm supposed to add them together to get c, I would need to know how far over does it go, how far up does it go, okay? That's finding the components, ay and ax. Same with this one, okay? If I know the angle, I can find by and bx. But to get my total, I need to know how far over did we go in total. So I take bx and ax, and I put them together. They'll equal the overall distance we went that way. Okay, and then same with the y's. Okay, we went up some more. I put the up and up some more together, and I get this side, the vertical part of that. And then it's Pythagorean theorem, trigonometry calculation, and you're done. Okay, here's the good news. Once you learn that pattern, it's the same for every vector addition question. Okay, draw the diagram. find the x and y components. Add the x's together, add the y's together, do Pythagoras, do trig, done. It's always the same steps. Okay, once you learn the steps, you'll get faster and faster and faster. Okay, the first couple times you do a big vector addition question, it's probably going to take you like 20 minutes. Okay, but as you get faster and faster at it, that same 20-minute question, you could probably wear that down to 7 minutes, 5 to 7 minutes. Okay, you'll get faster as you go. But like any other skill, the only way you get better at this is practice. Okay, we're going to spend quite a bit of time in class practicing. Okay, but you also have the worksheet booklet that's got keys and numbers and stuff. You know, it's got the answers there, the solutions, so you can check them. Okay, you do have to. The more of it you do, the faster you'll get, the better you'll get. Okay. Okay. I'm actually going to take that picture out, and I'm going to want you guys to try and draw the picture yourselves here. Should have done this before. You're going to remember what that picture looked like. Okay, I want you guys to copy this one down. Okay, and actually, before you copy it down, I'm going to change this. I'll actually write it so you can. Okay, 20 degrees right of vertical. So vertical being straight up, 20 degrees to the right. Okay. So copy that question down, and then what I want you to do, don't go any further than this, is to try and draw the diagram. Okay, tail to head, remember scale, okay, that kind of stuff. Let's see how that goes, and then we'll compare our diagrams together. Okay, so our first vector is 145 meters and it's 20 degrees right of vertical. Okay, so that means I need to draw a line that's vertical. Okay, and this line is 20 degrees right of it. So this is a skinny triangle. Right? 20 degrees, pretty skinny triangle. So since this is its horizontal part, that's the x component for the first one, and this would be the y component for the first one. Okay, and then it says vector b, oh sorry, I forgot to put the magnitude on there. This is 145 meters long. Okay, vector b, okay, is 105 meters, 35 degrees below the horizontal. So I need a reference line that's horizontal, and I'm going to go 35 degrees below that. So that might be a little bit long. I'm going to shorten it just a little bit. Probably more like that. Okay, and that's just where you want to check your scale, okay, as you're going along and make sure it's at least approximate. That line was way too long the way I drew it originally. Okay, so this is 105 meters long. This angle here is 35 degrees. I did make it significantly bigger than my 25 degree line. I didn't measure anything here, okay, but I don't need to as long as I'm at least close on scale. Okay, this will be x and this will be y. Okay, this x points that way. This x point, or that y points that way, okay, and that x points that way, that y points that way. All right, where would I draw a line that would represent the overall or total displacement of this object?
Oh, head to tail, so the bottom of the blue triangle to the Right there.
To there? Yep, absolutely. That's exactly where I would draw it. Okay, and then you could draw the triangle for this one here or inside. I like to keep it out if I can so it doesn't make my diagram look too cluttered. Okay, they can get kind of busy, especially if you've got a lot of overlapping triangles, so I just try and limit it if I can. It's not always possible. Okay, so this would be the y component. It appears to be up. This would be the x component. It appears to be to the right. Okay. I can't figure out anything about the purple triangle yet. Okay? But I have the hypotenuse and an angle for both of the other triangles. Is that all I need to find out? Everything I need to know about any triangle. Really, like 2 pieces of information about any triangle gives you the rest of the triangle. Okay? Whether it's a side and an angle, or 2 sides, or whatever, you'll get it figured out. Okay? So let's go with the blue triangle. Okay? I want you guys right now to calculate y and x for the blue triangle. I'll give you a minute to get ahead of me. Okay? Calculate y and x for the blue triangle. Okay, so what I usually do is I just kind of leave a little space to the side of my diagram, and that's where I do my calculations. Right? So blue x is my opposite side, right? It's not touching that angle, so it's opposite. So I would go sine of 20 degrees times 145 meters, okay, and I'll punch that into my calculator. All right, so sine 20, close the bracket, 145. Okay, we're looking at 49.593. I'm going to keep all those decimals. I'm just going to write 3. Meters, and that is up. Okay, because that's what I have here, right? It's basically up and over. Okay, then for the y component, well, the y component is touching the angle arc. That means it's adjacent to it. So I would use cos for that one. Cos of 20 times 145. That's obviously the longer of the 2 sides. Okay, 136.255. Meters, oh, sorry, not up, this one's not up. This one's up. This one is right. Okay, so up and right. Okay, how many people have done the red triangle? Okay, let's look at the red triangle. I know I didn't tell you to, but let's do the red triangle. Okay, so in the red triangle, x is touching the 35-degree angle, so x is adjacent in the red triangle. Okay, so cos of 35 degrees for this triangle, okay, times the hypotenuse for this triangle, it's 105 meters. All right, so cos of 35, okay, times 105. All right, so 86.011. Remember, you're keeping all of those in your calculator, okay, and that one also goes to the right. Okay, and then for the y is opposite that 35-degree angle. So sine of 35 degrees times 105 meters. Okay, this will be the shorter of the 2 sides more than likely. Okay, so sine of 35 times 105. Okay, 60.226 meters down. That's where writing the directions comes into play. The reason I always write on there east, west, north, south, up, right, left, down is because I know I'm probably going to have some of my lines that are going to backtrack. Okay, and if they're backtracking, I need to know which things need to be negative and which things need to be positive. Okay, everybody with me so far? Okay, so if this was a question on a test, this would be between 8 and 10 marks. Okay, you would get a mark for your diagram. And you would get a mark for each one of these calculations. Okay, so we're up to half the marks are already here. Okay. Now, what's my next step? I'm still trying to find my purple triangle here. Can I find any parts of my purple triangle now? Okay, let's find x first. Okay, looks to me like purple x just goes to the right. And both of my x components up top here also go to the right. So if I want to find purple x, what do I do with the other two x's? Just add them together. Okay, I'm adding the x components. Vector component addition. I found the x components, now I'm putting them together. Okay, so I'm going to take blue x, 49.593, and I'm going to add it to red x, 86.011. Okay, those were both to the right, so I can add them. And I'm going to take the actual numbers from my calculator. Now, if you have an older calculator, okay, or one that's not a graphing calculator, you won't be able to do what I'm doing here. It still works. Okay, I only got this last year. I can't go back now because you can do this. And you can go out and grab the numbers, which is like really convenient during vector addition. But if you have an older one, you just have to make sure you can, find them so you can write them down. Okay, so 86 plus the 49.59. Okay. So we are looking at 135.604 meters. And that is to the right. Okay, so I can label this one here 135.604. Okay, now one of my y components goes up. The other goes down. So if I add them, which is what I want to do, I have to make one of them negative. Or I could just subtract. I don't care which one you do. They're mathematically the same. Whatever makes more sense to you. Yes, technically it says vector component addition, but I know you guys can recognize it up and down are opposites. Okay, and same with east and west. So totally up to you how you want to do that. Okay, for me, I just do it by the letter of the book here, okay, which is 136.255 plus negative 60.226, just so I'm keeping up and down that way. Okay, now the reason I do it that way is so that if I get a negative number, I know which way it's pointing. But again, it's completely up to you. All right, so I'm taking my 136, gonna go way up for that one. Okay, and I am adding negative 60.225. Okay, so my resultant or purple y is 76.030 meters up. Okay, you don't have to fill these in on your diagram if you don't want to. Okay, it's totally up to you. It does get kind of busy if you're doing that. Okay, all right. I have the two sides now for my displacement vector. Can I find the magnitude of my displacement vector? Okay, how do I do that?
You would just a squared plus b squared equals c squared.
Right, use the Greek geek. The Greek geek is Pythagoras. Okay, spent his whole life studying triangles. He's the Greek geek. Okay, so we do Pythagoras here. So to get d, we're going to go square root of 135.604 squared plus 76.030 squared, but with all the decimals from our calculator. Okay, and guys, when you're writing down these steps, I don't expect you to write out all the decimals on paper. When you're showing me the steps, okay, sometimes I don't even write the decimals. I just know which numbers I'm doing. I put just like 135 and 76. That's okay for showing your work, but make sure on your calculator you include everything. Okay, so square root of that number squared plus that number squared. Okay, so the overall displacement for that object is 155.464. What's going on with my fives today? They're like abbreviated. Okay, 0.464 meters. Okay, that's the magnitude. What else do I need?
The meters east, or whatever it's called.
Right, I need the vector.
That one.
Yeah, vector, that v thing. Okay. Can I use any trig function I want now? I mean, every one of these numbers is a number I calculated, so there's no safety in using a given number here. They're all mine. All right, so you can use whatever trig function you want to find theta. Again, I'm a nerd, so I have a theta. Okay, so the tan to the minus 1 for me of my opposite side is 76. Okay, divided by my adjacent side, 135. Again, I'm only writing it that way. I'm keeping all the decimals in my calculator. Okay, I'm calculating theta with that. And so that's going to be, okay, second tan of the 76 divided by the 135. Okay, so I'm getting 29.278 degrees. And for me, that is north of east, because my arc touches due east and goes north from there. Okay, let's go back to our givens here. How many significant digits can my answer have?
4, 3. Oh, that's the number outside.
Right? The 20 degrees only has 2. That's why I changed it. I wanted to also throw in a significant digit thing here. Okay, yeah, 145 has 3, 105 has 3, 35.0 has 3, but 20 has 2. And I used it to calculate stuff. Therefore, my final answer can only have 2 significant digits. Okay, now, what's that going to mean when I have a 3-digit number?
We're going to do the math thing.
Scientific notation. Okay, the math thing. I'll go with that. Okay, we all call it whatever we want, but as long as we know what it means. Okay, so my overall displacement, this number to 2 significant digits is 1.6 times 10 to the 2. Okay, and that would be meters at, what's my angle going to be to 2 significant digits?
29 degrees.
29 degrees, right? The 2 doesn't round up, so at 29 degrees north of east. Okay, so the rest of the marks here, a mark for this, that's 6, 7, 8, 9, 10. You get a mark for every step. Show your work. And here's the added bonus. As long as your work is correct, even if you make a calculation error, I'm giving you method marks here. If you know the next step is to inverse tan, even if these numbers are wrong because you made a mistake further up, I'm still going to give you that method mark. Okay? Which means you could make a mistake early on, but if you show all your work and the only thing that's dead wrong at the end is your answer, you can still get 9 out of 10. Okay? I'm not going to penalize you because you can't type, because that's often what it comes down to. Okay, now if there's a mistake where you went sine of the wrong angle, okay, well that's different. Okay, like if you did the wrong angle, then that's an error in your method rather than an error in your calculation. Okay? Questions on how that works?
Does it matter which triangle you start with? You want me to start with the red one or the blue one?
It makes no difference. You're going to have both of those, but you can do them in whatever order you like. And guys, also, how many people are looking at this diagram and going, oh God, that is so crowded. It's like really hard. Could I separate those triangles completely?
Yes.
Yes. Okay. We do this sometimes with what we call the separate triangle method. Okay. Mathematically, it works out to exactly the same thing. Okay. But I can take this triangle and figure out its sides. I can take this triangle and figure out its sides. The only drawback to doing that is because they're not connected, you don't have this. You'll have to build this from here. But it's going to be 3 diagrams kind of separated in space, and sometimes it's a little easier to look at. Right? I'm totally okay with that because all of this work is the same no matter what method you use. Okay? I like putting them together because I need to see the big picture. I need to see them attached. I need to see how they relate in the end. But if that doesn't work for you, if you find it too crowded, draw one triangle, do the calculations. Draw the other triangle, do the calculations. Put your x's together, put your y's together, and then When you get to this point, now you can build that triangle. It's still gonna work out the same. It's just sometimes people find that easier to process. I'm okay with it.
For your direction,
Yeah.
do you always do like,
Oh, I put north of east. That's what you're asking, right?
well,
It shouldn't be north of east. It should be above the positive x-axis or above the horizontal or above right. I absolutely should not have put compass directions in there, so good catch on that. Okay, I should not have put compass directions on there. It should absolutely have been above the x-axis, or more particularly the positive x-axis, yeah. Okay, so no, don't just put compass directions in. Go with what the question gave you. I just get in the habit. We do a lot of compass directions, so that's totally on me.
If in one of the steps you do something wrong with like your method, but then the rest of your
Any method that's correct, I'll give you. Okay, but if you make a method mistake here, okay, but then you use that incorrect number down here, that's still fine. You knew you were supposed to take that number and use it right here. So you're adding the wrong number. You still knew this was the next step. Okay, so show all of your work. You're gonna get marks for it. Okay, do not be like that kid I had like 8, 9 years ago who refused to show any work. No matter how often I told him it's all worth marks, he goes, I don't need to show my work. Final exam, he'd written his math final the day before, didn't listen to my instructions to convert back to degree, wrote a single answer for a 10-mark question that was wrong. I don't know what he did. I assume it's because he didn't put his calculator back in radian mode. All I know is he got the wrong answer, and that was all he wrote. That's 0 out of 10. Versus, oh, I kept getting weird numbers when I did my trig. He should have realized that, because radian gives you way different numbers. Okay, but he didn't, and he got 0 out of 10 on a question I'm sure he knew how to do.
What's the rating for
Math?
math?
Beyond that, I couldn't really say. I don't math much. Yeah, it's something in math. Okay, take about a, let's say 4-minute break here within the classroom. Get up, walk around, talk amongst yourselves. Then I'm gonna put one up for you to try, okay? On your own. So for the diagram for this one, our first one is 80 meters due east. So okay, 80 meters due east. Then we go 25 degrees north of east. So give myself a due east vector, okay, to kind of measure my angle from. And 60 meters. Okay. Probably could have been a little longer or a little shorter on the 80, but it'll do. It'll get the point across. Okay, Y and X. Okay, last part of my diagram, I need a line that represents the total. That's this line here. Okay. You can draw it the way I did, or you can draw it over top of your other lines. That's totally up to you. You'll just get the complementary angle to what I get, okay, at the end of all this. Okay, so your diagram should look something like that. All right. Next step, find the X's and Y's. Okay, so I'll give you a few more minutes before we go into that part. Okay, so we said the next step is finding all the X's and Y's. For the black line, that's pretty easy. X is 80.0 meters east. What's Y? 0. Doesn't go north or south, right? So 0 meters. Okay, so that part's easy. Then we got to do the green triangle. Okay, this will involve some trigonometry. X is adjacent to the 25-degree angle, so that'll be the cos of 25 degrees times 60 meters. Okay, so cos of 25 times 60, so that side's 54.378 meters east. Okay, and then Y is the opposite side, so sine of 25 times 60. Okay, so that side's 25.357 meters north. Okay, so now that I've got those, can I find red X and red Y? I can. Okay, I know that red X is 80 plus green X, right? It's the full length going east. And red Y is equal to green Y because that's the only time in the entire trip we go north. Okay, so that would be my next step here. Okay, so red X will be 80 plus 54.378. 80 plus 54.378. Okay, so red X is 134.378 meters. Okay, and Y is 25.357 meters. Okay, because black Y is 0, and anything plus 0 is itself. Everybody with me so far? Okay, how many people have the rest of it done? Okay. So now that I've got those two numbers, now I can calculate D. All right, so Pythagorean theorem calculation there, square root of 134 squared with all the decimals in my calculator, plus 25 with all the decimals in my calculator squared. Okay, and again, you can do that. I don't mind if you don't write all the decimals in your work, as long as you keep them in the calculator. Okay, so 136.750 meters. Okay, now that I have that, now I have to calculate what theta is. Okay, so theta is going to be the square root, or sorry, not the square root. I have to do trig here now. Okay, I'm going to use tan, so tan to the minus 1. I'm going to put the opposite side for my angle, that's x, 134, divided by the adjacent side, for mine that's 25. If you drew it the other way, that's fine. All right, so second tan of 134 divided by the 25. Okay, so I've got a big angle, 79.314 degrees. And for me, that is east of north. Okay, how many significant digits can my answer have? 3. Everything I was given had 3. 80.0, 60.0, 25.0. Okay, so everything has 3 significant digits. So my final answer would be that the displacement is 137 meters at, for me, 79.3 degrees east of north. Or you could have at 10.7 degrees north of east. Okay? If you drew the triangle the other way, that's the number you would have got. All right? Questions on that? Okay, that's what we're going to be working on for a while. It's going to get a little bit like crazier. We haven't had any that really backtracked on each other yet, that where scale would be really important. We're going to do a few of those, and that's where you're going to realize the part that trips people up the most is the diagram. Okay? The diagram is without a doubt the thing that trips people up, especially if you've got one that's north of east and then one that's like west of south, and they go right back and there's like a tiny little result like this. Okay, that's where the scale of your diagram is important, because you'll do your math and you'll be like, I don't know, that's not how my picture looks. But again, it's probably your picture that's wrong. It's probably your math that's right. Okay, let's say I'd like you to get the diagram for 2 and get started on 2. Okay, get the diagram done, see if you can start getting x's and y's calculated for that. We'll probably run out of time, but let's see how much of number 2 we can get down. Okay, because sometimes this can get confusing with a triangle like this one. Okay, so we got 15 meters, 15 degrees north of east. All right, so we go like this. Okay, this is 15 meters. Whoop, that's not 15 meters. Let's start that over again and do it right. Okay, so here's due east. Okay, we go 15 meters. Okay, that's probably be a little bit bigger than that. Let's say like this for scale, like that. Okay, and this is 15 degrees north of east. This is 15 meters long. They could have picked different numbers, but they didn't. Okay, now, if you're ever wondering, like, how do I know where to draw this line? Okay, what I always do is, like, sometimes, and I see people do this on the final exam, sometimes they try to hide it, but they shouldn't. They should just do it. Okay, I put my hands north, and then I go west of north. There's my triangle. Okay, it's right between my fingers. I do that on the board like this. I go west of north. North is my reference. So I go north, and then I go 5 degrees west of that, and now I've got my triangle. And this is 13 meters. Okay, so if you're ever confused by the compass directions, whatever the second direction is, that's your reference. Draw a line in that direction, and then go in the other direction. Okay, in this case it was west of north. So I drew a reference north, and then I went west of it 5 degrees. Okay, and you'll get your triangles right that way. Okay, because one of the very common mistakes is to get the diagram wrong because you went south of west instead of west of north. Okay, it's really easy to mess that up until you get good at it. Okay, so that can kind of help, right? So that means your overall should look like this. Okay, so this would be its y, this would be its x, that would be its angle. You could draw it over top of your existing lines if you wanted to. Nothing wrong with that. X, y, x, y. Okay? It's as long as you can get to the right answer when you're done. I'm okay with how you. Yeah, that's fine. If you know how to do the X and Y part without the blue diagram, go ahead. I would still give you full marks for that diagram if that's what I said.
Good morning, everyone. Please join me